Hello everyone, I'm very happy to be here to present about a topic that I'm very passionate about, which is how to write the next generation of user experiences using Unity and augmented and virtual reality. My name is Davide. I'm a senior software engineer. I live in London. I've started working with these technologies in 2017, firstly using HoloLens devices and lately more consumer-friendly headsets like Oculus Rift or HTC VIVE. In the past, I've been awarded 5 times Microsoft MVP for my contribution to the community. I like to share my experiences on my blog or on GitHub. But let's introduce the agenda for this presentation. Firstly, we will introduce the concept of mixed reality, and then we will start by writing a simple virtual reality application using Unity and the SteamVR plugin. Then we will move more on natural forms of interactions like vocal commands or hand tracking, and to finish a glimpse of HoloLens development using the Holo Toolkit and lately Mixed Reality Toolkit. Let's introduce the term of mixed reality. Mixed reality is the blending of the two worlds, the physical reality where we usually live, and the digital reality which is generated by a personal computer or a hardware device. And this is where the magic happens, is where you can enhance your environment with virtual objects or holograms in our terminology. And you can, for instance, have virtual screens on the environments on your walls, or you can try a new type of furniture without buying it, and so saving some money. Let's see now the different types of devices that we can find in the market. To refer to these types of devices, we can look at the concept of physical and digital reality spectrum that was introduced in 1994 by Paul Milgram and Fumio Kishino in the paper A Taxonomy of Mixed Reality and Visual Displays. If we put in one extreme the digital reality, we can find that category of devices like Oculus Rift or Windows Mixed Reality immersive devices, which are usually occluded devices. You cannot see through on those types of devices, apart from latest development, where you can use a pass-through cameras. But generally speaking, you cannot see through. And you need to generate a full 3D environment. And other types of devices are the other category where you can see through. HoloLens is an example of those, or Unreal Light or Magic Leap Ones, for instance. In these types of devices, you won't have to generate a full 3D environment, but you will have holograms that can be pinned in your environment, for instance. Why mixed reality? This is a question that I often ask also to myself. And I think mixed reality is a new computing platform. So we are moving from 2D screen interfaces to 3D interface in the space. So in the future, we will have more of these 3D interfaces coming to us, and probably as a developer we will be involved in thinking about no more 2D screen visual interfaces, but on the 3D spaces. It is estimated a lot of revenue in the next years. Some studies like the Goldman Sachs report have found that by 2025 there will be 80 billion revenue, so that's a good economic turnout for that. And the mixed reality is already revolutionizing a lot of processes like gaming, video entertainment, or healthcare. I was studying recently, for instance, some interaction of patients with the doctors that can be studied by virtual reality, or virtual reality for curing illness, or think about the possibility of using virtual reality for exploring real estate applications, or a building before it gets the construction gets started, or in education. Training is a big sector for virtual reality, or engineering and military for simulators, for instance. How can we develop for this type of experiences? We need to think about the application a different way, because now we are no more in the 2D world, but we are in the 3D world. And when I started looking at these 3D experiences, I was looking for a way of providing a proper immersion to the user. And I found this concept of illusions that was introduced by Professor Mel Slater of University of Barcelona. He mentioned that a great experience should include three types of illusion. The first type of illusion is the place illusion. So the sensation for the user to be there. So to do this type of illusion, we need to provide a good virtual environment with the proper scaling in order to give to the user the impression to be there. And that's very important. But this is not sufficient. This is not sufficient. For getting the user the sense of presence in the virtual environment, we need also to provide additional types. The other type is plausibility. Plausibility means the possibility of interacting with the environment and the possibility of touching objects, of if there are virtual agents, having some virtual agent interact with you, looking at you when you are in the environment. And the third type is embodiment. Give a representation of the body of the users into the environment in order to give him or her the impression to be there. And the first experiments that I was doing with embodiment were quite poor, to be honest. I was trying to represent a full body of myself in the environment, and it was the illusion sometimes. I think that other implementation like this one that you can see in the video by Oculus, you can see how you can provide embodiment just visualizing simply the hands and the joints, and just by using the motion controller of the headset, you can do this type of experience that can be brought to the next level now with hand tracking, which is present devices like HoloLens or Oculus Quest, for instance. Let's move now to the development tools. Which development tools are available for these applications? I classify these tools in three main categories. The first categories are game engines like Unity or Unreal Engine 4. With these environments, you can import 3D assets generated by softwares like 3D Studio Max or Maya, and you can just apply transformation or physics effect to these objects. And this is quite useful for having quick prototypes or great Unity or virtual reality experience already available and quickly. And they are quite productive environment. Other APIs permits to have a probably better performance like OpenGL, DirectX, or Vulkan, but clearly you are going to a lower level, and then the efforts for developing these experiences are clearly more. And the third type of environment, WebVR, WebXR, with frameworks like A-Frame or Babylon.js, where you can use JavaScript for develop application for virtual reality or augmented reality. And this will be an area of growth for these type of experience in the future for sure, because these are skill sets that are present in the market. In terms of languages, C# and .NET for Unity. Unreal Engine 4 is using C++. JavaScript clearly for WebVR or WebXR. Let's see how to create now a virtual reality application using the new way of interaction that are required by these apps. Usually, we can categorize two types of interaction. The first is pointing objects or selecting objects in the 3D space, or for grabbing objects. This action usually can be done by the motion controller and are quite obvious if you want to interact with the environment. And the second way is moving into the environment using the concept of locomotion. And this is quite important because you cannot give motion sickness to the user. And so you need to add an extra care when designing this type of applications and interaction in the environment. You can do that by eye gazing, for instance, pointing with your eyes a specific location in the environment, then be teleported to that, or by using the motion controller via some visual effects that can be applied for pointing to a specific location in your environment, or continuous movement also in the experience, which needs to be also constant to not give too much motion sickness to the user. So let's start now to develop a small demo with Unity. So let me jump to Unity and see how to create a quick virtual reality experience using the SteamVR plugin. Usually, you can start via a new project in Unity, and Unity also provides some simple assets that can be used in your scene to get started quickly. I have used the default asset here on Unity. You can see I have a workbench with a table, with a hat, and some instruments. I can start playing with it. So the first step is to enable virtual reality in your project. So you can go to the build settings of Unity, and in the build settings, select the virtual reality mode. You can do that in Unity 2020 with the XR plugin management. I have applied here the OpenVR plugin, which is available in the SteamVR GitHub. And in this way, you can write experiences that are spanning multiple headsets, not only Windows Mixed Reality, but also Oculus or HTC, for instance. And so you can write an application, white advance, and deploy multiple times on different devices. So I have enabled the OpenVR plugin here, the application type is scene. And in this way, I am already able to deploy this experience on the device and able to immediately start using it in my headset. But I need to take care of additional stuff before. I need to put a camera, I need to put a representation for my hands, for instance, for my controller, etc., etc. So for doing that, you can use the SteamVR plugin from the marketplace, and you can import it by going here on the Windows Package Manager or the Asset Store. Asset Store has been now deprecated from the Unity 2020, so you need to use the Package Manager. From the Package Manager, you can use the packages section or the My Assets section and import the SteamVR plugin. Using the SteamVR plugin, you will have a new folder in your project called SteamVR, from which you can choose your assets, your prefabs, and you can drag them into your scene to get started user. The most important prefab in SteamVR is the player prefab. For enabling the cameras and for both eyes, your experience, the player prefabs makes it all available in your scene by simply dragging this player prefab in your scene. And you can see there are a lot of properties and a lot of fields in this particular prefab, like the left hand, the right hand, or the VR camera. And you can also customize it if you want, just going into the hierarchy of the objects and just modifying, for instance, the assets of the controller, etc., etc. So one of the simple implementation that I would like to add here is teleportation. So for adding teleportation to my experience, I need, of course, to import the teleporting assets from the SteamVR plugin. And if I just drag it in my scene over there, I can see a lot of options that enable the modification of colors or areas where I want to enable teleporting, etc., etc. And if I want to teleport to a specific location, I can use the prefab teleport point over there. So you see here, I just put a teleport point in this position. It means that the user with the motion controller will be able to be teleported to that particular position in time, in the place. And I decided also to add an additional level of interaction and using the teleport area, which is available in the SteamVR plugin. Using the teleport area associated to this plane in my scene, I can enable not only the teleportation on one single point, but on an area of my environment. And that's perfect. I am ready to go. If I press play now, I can already deploy my application to the device and start teleporting around. But let's add some additional interaction first. Apart from the movement in the environment, I would like also to add some interaction with objects. So here I have some object on the table, for instance, and if I wanted to enable interaction using SteamVR, I can simply add an interactable script from SteamVR, interactable, just drag the interactable script directly on my safety hat, for instance, and then I will be able to manipulate this object with my controller, which is pretty amazing. And a functionality that I found quite useful when developing for VR is the characteristics of being able to snap turn, so to visit my environment. So I added here a simple script associated to the player, which I call the rotate player. Let's go and look at this script. So this script is associating to the game object some transformations that can happen when the user trigger the left or the right direction in the joysticks. When you do these types of action, and you can simply apply a transformation, a rotate on the left, on the right for a number of degrees. So you can see here by this example that when occurs a left or right interaction with the motion controller, I can just simply apply a rotate on the right or on the left just by modifying the transform.rotate property of the player. And doing this transformation is quite useful to guarantee that the user is able to visit the 3D environment and without losing this sense of presence, of immersion that we mentioned earlier. So done that, we added locomotion, we added the interaction, we added a bit of snap turn. If we go back to the slide now, we can see the experience running on a Windows mixed reality headset. So you can see here, I can look around in my environment. I can apply snap turn by using the controllers. So I can visit the environment in 360 degrees. And I can use teleport for moving in the teleport area that I defined previously. You see how SteamVR already enabled all this functionality by default. And in this way, by enabling also the creation of simple prototypes very, very quickly. And it will take just a few minutes once you are proficient with this SDK to create just simple application like this. And then you can manipulate object and applying different scripts like throwable. You can also throw the object. You can see how the physics is applied, etc., etc. So that's pretty cool. And you can see how the code is very limited because you can just start implementing this application from scratch with very little effort using Unity. Let's see how to implement a more natural form of interaction now, because when I started developing these apps, I was feeling immediately the need to add more natural forms like voice recognition, for instance. And some examples of natural language understanding, which is also enabled by services like cognitive services, for instance. So my first experiments were with the Unity keyword recognizer. Using the Unity keyword recognizer is quite simple, and it's also very effective because if you need to recognize simple phrases, you can just pass these phrases and words to the constructor of the Unity recognizer. And automatically, when these words will be recognized, an on-phrase recognized event will be triggered, and then you can do different action when this event is fired. You can, for instance, show some UI on top of the user. In this example, I decided to show a frame per second counter to the user in order to check the performance of the virtual reality app while developing on it. And you can see just when the event is triggered, you can check the word that has been captured by the microphone, and you can then show an FPS UI, which is quite cool and works quite well. However, when you really want to provide a more natural form of interaction, you probably don't want just to recognize single words, but you want to recognize a category of phrases. And then if you think about the possibility of giving help to the user, you can ask for help just saying the word help, but you could also require help by saying, what should I do now? Which doesn't contain the word help. So in this case, this is quite a more complicated problem. And for solving this problem, we can leverage some techniques using machine learning or artificial intelligence, like the one provided in the cognitive services, for instance. And we can not only capture the phrase via the microphone, but we can get these strings, send these strings to a cloud service like Azure, and from this cloud service, recognize if the phrase contains some intents for the user, like help, and with this intent, execute some action in our Unity Hub. So for experimenting with this, I started creating a new language understanding application in Azure, and then I linked this application to my virtual reality experience by creating some intents that are the action that the user wants to do. So you need to usually provide to the cognitive services a list of intents and a list of sample data that you want to be recognized in order to train the machine learning services. So you can see here some example. For asking for help, I could use different phrases. I can provide all these phrases to the services, train my model, and then use this model from the Unity app. Compared to the previous method where we were using the keyword recognizer, I had to use this dictation recognizer this time, as I wanted to capture all the input from the microphone. And when I got an input from the microphone, I had to send these strings recognized by the dictation recognizer to the cognitive services. And when I have a result, a valid result, I can, for instance, show a different UI on the screen on doing different actions. In this case, I just got the string using a Unity web request. I sent the string to the cognitive services, and then I processed the result of the recognition. And if there is a top scoring intent, like the help that I was defining before, and this event has a good score in terms of a probability, in this case, I decided to capture only the intents that were recognized with a 65% accuracy, at least. So this was then triggering some actions like showing and handle help UI for the user. So in this way, we are not able to process only single words or phrases, but using full machine learning recognized services in our Unity app, which is very powerful and very cool. So to test all it together, I decided to take my prototype to a next level and see if it was possible by using these Unity interactions and locomotion properties, see if it was able to just write a simple game, right? And that is possible.
Can you help me?
You can see here I can use just a locomotion to move in the environment of this mysterious engine. I can use voice for asking for help. I can collect assets. I can move with the asset in the environment via the interactable script saw before in the SteamVR, and I can open doors or can do stuff in the environment. And this is quite interesting because by only using interaction and locomotion and some voice recognition, I can write a full working game. And this is also
Can you help me?
a great learning experience if you want to learn how to develop for virtual augmented reality.
Show me the score.
All right, but clearly when you're writing these types of apps, you immediately notice that if you don't provide a good frame rate for the user started to get the concept of motion sickness, which is a very important aspect to evaluate when writing these types of applications. So for optimizing performance, I found some techniques that can be useful. This is quite not an exhaustive list, but it is something that I found useful while developing my virtual reality experience. So the first one is if there is an object that is not moving, mark it as static, as this is helping the batching and the rendering on the two screens of the objects. And clearly, sometimes can be difficult to find all the objects that are marked or not marked as static in the scene. So I came out with this simple script that can be applied to every Unity object. So you can find if you have some static or non-static object in the scene. And that's quite useful. And the second one is lighting. Lighting is a very expensive operation when using virtual reality apps. So I found that the usage of baked light instead of real-time lights is very good to guarantee the performance of 90 frames per second, for instance, in virtual reality devices like Oculus Rift or Windows Mixed Reality, or 72 frames per second in Oculus Quest, for instance. And the third one, to avoid not performer code at runtime. So code like get component or debug.log is very performant and should be avoided in the update method of the Unity scripts. You can see an example of caching strings also. Every property, since the strings are immutable, should be cached for proper performance improvements. And every operation should be cache like the one of get component, get executed on the awake method, and then reusing this object in the update method on trigger. And let's move now towards the augmented reality side of stuff. We mentioned now virtual reality apps, but what about not using anymore the controller, but using our hands? And this is clearly functionality that can be used in devices like Oculus Quest 2 or HoloLens 2. And this is opening a new scenario of applications for augmented or virtual reality. And a very good reference implementation and toolkit for this type of manipulations for interacting with buttons or objects in the 3D space is for sure the mixed reality toolkit, which is now also supporting devices like Quest. And you can easily, as you can see in this demo, move into the environment and represent your hands and interact with buttons or with objects. And also play a piano. Not sure that playing piano is a good activity for virtual reality, but really you can see the advantages of using hands instead of motion controllers. Or for instance, if you want to discover objects like representation in the 3D space of in this case just simple 3D object, but I like a lot of these manipulation script available in the mixed reality toolkit that enables the two hands manipulation object, and the possibility I think are endless because you can just explore these objects. You can put, I don't know, big motors in manufacturing and explore those, or exploring environments and other locations without having to be there physically. So that's pretty amazing stuff that the mixed reality toolkit team is doing, and is also available. It was initially available for HoloLens, but now is spanning a lot of other devices like Quest, for instance. And let's move now to the last topic of the presentation, which is how to use these toolkits for develop for HoloLens. So when I was doing my first experiments with the HoloLens 1, I was writing this Hello World app for augmented reality, which is grabbing a camera picture, sending this camera picture to cognitive services, and then recognize with the Vision API what the objects are in the environment, and then using speech available in HoloLens to say which object has been recognized. And clearly, this is taking advantage of the various sensors that are available in the HoloLens 2, which are not only camera, but depth cameras, for instance, or hand tracking or eye tracking. So you have a lot of possibility for this kind of applications. And as we saw before, it all starts by creating an app, in this case, a computer vision app compared to the previous one that was a language understanding one, and then capturing a photo from a picture from the camera using some packages if you want to create a prototype, for instance, from UWP before deploying to the HoloLens. In this case, I decided to create a small application UWP just to test that everything was working fine. You can see here I can capture my picture from the camera. I can send the picture to the cognitive services. Cognitive services are returning back a JSON describing what the object captured is with a very good confidence. And then I can just import this DLL previously built for UWP in my HoloLens app, and using the mixed reality toolkit, putting some status tags or using speech recognition, and then send them via the HoloLens device to the cognitive services, and then recognize
Analyze.
Analyzing
object.
Picture.
Think about it
screen
at the
television.
various possibilities when we will be able to and the hardware will permit to have these functionalities in normal glasses. We will open a new category of apps, and that's pretty amazing. And of course, with the latest development, you can use a lot of additional services on the Microsoft Azure platform, like remote rendering. Think about the possibility of rendering millions of polygons in your mobile device. Usually a mobile device cannot render more than 200,000 or 300,000 polygons, while desktop VR can handle 1 or 2 million polygons. But clearly, if you have very high details polys or models, that could be, for instance, in real estate or representation of buildings or photogrammetry, they could take 150 million polygons very easily. So services like remote rendering are enabling a new range of experiences for the users, or spatial anchors for pinning 3D object not only in your physical room, but in the real world, in the real environment, in order to pin some stuff in the streets, for instance, or in the stores, or object anchors, which has been latest developed from the mixed reality services. So to summarize what we saw in this presentation, we started looking at mixed reality and the concept of blending the two worlds, and then we started developing for mixed reality using VR interaction and VR locomotion. And then we moved to more natural form of interactions and augmented reality stuff using vocal commands, hand tracking, and some glimpse of development using HoloLens. And my key takeaways when started working with these apps is to check the performance early and often to avoid motion sickness, because this is very important. And clearly, there is no substitute for testing these apps in the device. Test frequently using the target device, and design properly the experience using the 3 types of immersion that we introduced before: the place illusion, the plausibility illusion, and the embodiment illusion. And use cloud services to enhance the user experience. And I would like to leave with this quote about Arthur C. Clarke from Profiles of the Future, that any sufficiently advanced technology is indistinguishable from magic. And thank you very much. The slides are online on my site, and I'll be reachable on Twitter or via email if you have any question. Thank you very much again.